Okay, question number 16 from the review sheet. Line AB is tangent to circle with center C. Find R, the length of the radius, for the diagram below. If BC is a radius and AB is a tangent segment, then the measure of angle ABC is 90 degrees because of the radius perpendicular to a tangent theorem. So therefore, I have a right triangle, and I can use Pythagorean's theorem. 17 is the hypotenuse, so that would give me r squared plus 15 squared equals 17 squared. 15 squared is 225, and 17 squared is 289. I would subtract 225 from both sides, and I would get r squared equals 64. Square root both sides, and r is equal to 8. Okay. Question 17. Circles P and Q have radii 12 and 7, and they are tangent to each other. Find the length of their common external tangent AB. Show all your work. Well, if circle Q has radius 7 and circle P has radius 12, I would draw that in, and I would also remember that because of the radius perpendicular to a tangent theorem, that those are both right angles. I also know that since the two circles are externally tangent to each other, that their line of centers is continuous. So that would give me 19 for PQ. Now the key to this particular problem is to draw a segment from the center of the smaller circle perpendicular to the radius of the larger circle. So therefore, I have created a rectangle and a right triangle. Since this quadrilateral is a rectangle, if BQ is 7, then its opposite side is 7. 7 plus 5 is 12. So I have a right triangle with one leg of 5, one leg of x, and a hypotenuse of 19. And since this quadrilateral is a rectangle, if I can find x, then I will have the length of AB. So the right triangle allows me to use Pythagorean's theorem, and I get x squared plus 5 squared equals 19 squared. So x squared plus 25 is going to equal 361. If I subtract 25 from both sides, I'm going to get x squared equal 336. I'm going to square root both sides, and I'm going to realize that 336 is 16 times 21. So therefore, x is going to be 4 radical 21. Be prepared to find the exact value for question number 17, the common external tangent segment problem. All right, question number 25. Question 25 says that you're supposed to find the measure of the arc cut off by a chord 22 centimeters long in a circle with radius 16. So first draw a chord. Here's chord AB. Chord AB is going to create arc AB. So the question is really asking me to find the measure of arc AB. So I'm going to draw a radius such that it is perpendicular to AB, thus bisecting AB. So the 22 becomes 11 and 11. If a radius is perpendicular to a chord, it bisects the chord and the intercepted arc. So arc AB is also bisected. So now I know that the measure of arc AC is equal to the measure of arc CB. The key in finding the measure of arc AB would be to draw a radius to one of the endpoints of the chord. So the radius is 16. I have a right triangle with one leg of 11 and a hypotenuse of 16. Since the two arcs are equal, if I can find one of these smaller arcs, I can just double it. And since this arc is equal to its central angle, if I can find x, if I can find the measure of that central angle, I'm basically done with my problem. So with respect to this angle here, with respect to the x degrees, I know I'm going to use sine. It's going to be a trig problem. And the reason I know that is because 11 is the opposite side, and 16 is the hypotenuse. Don't forget the infamous SOHCAHTOA as a reminder of which trig function to use. So the sine of x is equal to 11 over 16. I'm going to divide out, use my calculator. 11 over 16 is equal to 0.6875. Go 4 places. To find x, I'm going to take the inverse sine of 0.6875. And that will give me approximately 43.4 degrees. And I double that to get the measure of arc AB. So I have 86.8 for number 25. You're going to have to draw the picture for Monday's test. Question number 26. In circle with center O, segment RS is 28 centimeters long and 10 centimeters from the center. So it's only 10 centimeters from the center. Distance is measured perpendicularly. What is the radius of that circle? Well, if a radius is perpendicular to a chord, it bisects the chord, so that makes that 14, and it makes this 14. And if I draw the radius here, these two actually meet, right? So the radius can be found using Pythagorean's theorem. 10 squared plus 14 squared equals r squared. So 100 plus 196 equals r squared. 296 equals r squared. Be prepared to answer this as an exact value. 296 is 4 times 74, so 2 radical 74. Once again, you're going to need to be able to draw the picture to answer this question on Monday's test. Questions 27 and 28. 27. To find x, I realize that this angle with 80 degrees is an inscribed angle. So the inscribed angle is at half of the intercepted arc. So if this is 80, then x is going to be 160 degrees. Congruent chords give me congruent arcs, so y and z are going to be equal. There's two ways to do this. I could go 360 minus 160 and give myself 200 and divide that by 2. Or at the beginning of the problem, I could have said that the interior angle sum of a triangle is 180. This is an isosceles triangle, so these two angles are equal. The two base angles are equal. 180 minus 80 is 100, divided by 2 is 50. These are both inscribed angles, so I would double those to find y and z. Question 28. I have an arc of 60 degrees. I have two congruent chords, so therefore I have two congruent arcs. So let's say there was an h out here. Z would be equal to h. Y is a central angle. It is equal to its intercepted arc by the central angle theorem, so y is 60. X is an inscribed angle. It's half of its intercepted arc, so x is going to equal 30 degrees. 360 minus 60 is 300. I have two equal parts, so each of those parts is going to be 150 degrees. Good luck tomorrow. I will be at school, as always, around 7 o'clock. I'll probably be in my room so that I can give any extra help that's needed. See you then.